Okay, I've been asked by a few people if I could do a circuit diagram of what it is I've been doing. When I get to work, hopefully I can get this copied and done some way that I can put it into an electronic format. But basically this is a quick circuit diagram of what it is that I've been using. I'll just hold this here for a little while, trying to keep it still, because yeah, using a phone's probably not the best way of doing this, but there we go. You have to start somewhere. Okay, basically if we come in onto the board, this is the pilot signal coming from the charger. When you look in your chargers, your wall chargers with a tethered lead, when you're looking at the cable, you'll have a live, neutral and an earth, which are probably going to be 6mm large cables. And you'll have a smaller cable. It's that smaller cable which is a pilot signal, and that basically takes a 12-volt DC signal and a bit of a square wave plus or minus 12-volt signal as well at various times. And as we look, this signal will now come in, and we'll fit this relay here, a relay contact normally closed, and then we just carry on and let it go into the cable into the car. For people that are interested, if you've got a dumb charger for this, just by breaking this wire here, if you were to put a small time clock in, or if you have one of these smart relays, I believe you can get from Alexa and things like this, if you were to put that relay in that signal, by breaking that signal you will stop the car from charging. So basically you could plug your car in, and your car will see the plug at the end and know it's plugged in, but while that relay is open the car won't charge. And this is just on a dumb charger, nothing special, the sort of charger that you can just plug into your car and it charges straight away and you don't have to do anything. Just by adding this contact in here, opening it, it's exactly the same as plugging your car in, that when it comes time to charge, that contact, once it's closed, it will be just like plugging your car in and it will start to charge. So that really is a very simple way for anybody with a dumb charger to make it sort of semi-intelligent, so you can put a time clock in or some other system to tell the car when you want it to start and stop charging. And I say, by removing that signal, so if you're charging the car and you suddenly open that, the car will stop charging, and when you close it again it should start to charge again. I'm not going to say it will guaranteed on every car, because as we found with the MG, not all cars belong, or not all cars follow the protocol as quite as well as they should. Anyway, on to what I've been doing. So I use this relay contact, and basically the relay contact is obviously with a coil. I take 5 volts to the coil from the Uno, and that can be picked up off of any of the power pins on the Uno, which are marked up at 5 volts. We have a diode across the coil, and it is in reverse action, so it's blocking the voltage. That's there for protection of the transistor, which we fit down line. And the transistor here we pick up from pin 8 on the Uno. We feed the base through a 1 kilo ohm resistor and a 10 kilo ohm resistor from the base down to earth. And all that means is just that when this voltage here is a positive voltage, i.e. 5 volts, the transistor will switch on and close the relay, and when that 5 volts disappear, the 10k just makes sure that this is down at 0 volts to make sure it stays switched off. And it comes across to the 0 volt, and if you look on the Uno, they're marked up as 0 volts or ground. That's the connection there. So that's basically how we're controlling the coil, which is doing the switching of the pilot line. We then come down pin 7 out of the Uno. We go into an LED, and then that just goes to a 1k ohm resistor and down to ground. And that I use as a status on the board. It just gives you some indication so that when you make an adjustment later you can tell what the board is actually doing. You can tell looking at the screen on the laptop, but it just gives a status which you can look at and you can see, which is quite nice. Again, our pilot line comes down and we come to the section here. We have to go through a diode, so the positive value will go through the diode. We come into a 4.7 kilo ohm resistor, and then on this, then going from there, we have another 10k ohm resistor down to ground, and this has got a 4.7 volt Zener diode across this resistor. That is purely there to give a little protection for the Uno, because we want no more than sort of 5 volts to be fed into the pin of the Uno. And I say, from this point here we come down and we feed into pin 3. This is detecting our pulse width modulation, and it's basically given a very sharp square wave signal which the Uno can read, and it looks at the edge to determine the pulse width, and that goes in on pin 3. And say basically in diode through to earth. Important, the 4.7 Zener there. Then moving down a little bit more, we do a similar thing again from the pilot line. Another diode, 5 kilo ohm resistor and 100k potentiometer, and again we come through resistor, potentiometer, down to ground. I will make a note here, at the same point we connect the ground or the 0 volt down to earth at the charger. It's important because the car uses the earth as a return path, so we need that connection to the earth terminal at the charger. Across this pair of resistors we have a 1F capacitor, and this basically gives the smoothing, which gives us a nice stable voltage, because the signal coming in here is a pulse width modulated signal, and it can go down to quite a small pulse width. But with these values I found that it gives quite a steady voltage with very little change as you change the pulse width from 10% up to about 70%. Not that we go that high on the pulse width in the UK because we're limited to our 32 amps charging. So yeah, basically this is our signal. We pick up off the potentiometer through a 1k resistor, and we feed that into the Uno again on the analog 0. So that's going to be measuring the voltage there. And that basically is all there is to the circuit. Now, before people jump on, I'm no great electronics engineer, I play. But generally that's seeming to be working quite well, and the voltages and the checks I'm working with it all seem to be quite reasonable. But anybody see things I've done wrong, then let us know, and we can probably adjust it. But that does seem to work. I'm just sort of holding this a little bit so you can actually see that diagram. So I will try and get that into a soft copy at a later date and get that posted somewhere. As for the parts that I've built it from, well, that's the little Uno board, which basically bought off eBay. You can find those from about £3 free delivery, a couple of pound from China, up to about £4.89 if you want to buy it from a seller that's already in the UK. You can get these boards. They're a nice little board. You can get them, they'll come with a lead, so you can plug it into the laptop to program it. If you've done programming with these, I don't need to tell you how easy it is. For people who haven't done any programming, the software is all available free online, and that's all you need is that board, the software, which is free online, and you're basically ready to go to load a program. So it's wouldn't cost a lot of money to load a program into it once you've got the program there, which is not too difficult. And the other thing I've used is the prototype board. I just bought a batch of these from, again, China. These maybe a pound, couple of pound from China, and these, as you see, will basically just sit over the top and you have some pins which you can then put into them, which we have like these pins. You can put them through and basically pick up what you need, and you can build your circuit on the top, and that's what I used. I was a little bit lazy. I say on the circuit diagram I show a relay, a coil and a transistor and a switching circuit. Purely I was lazy. I have this around, which again bought from China, probably bought about 20 of them because at the price they were so cheap. Yeah, couldn't even buy the relay for the cost that these cost me from China, and they've got all the switching and everything on board. Not fantastic for mains voltage because you can see the clearance on some of the tracks needs a little bit of work. I have used these with mains voltage, but I've done some adjustments to that board and got rid of some of that track and got a bit more clearance. But for the low voltage we're working with, perfectly adequate. Nice and simple to use. You just got a 5-volt power supply, 0 volts, and your signal line in when you want the relay to operate. But yeah, I mean, mine is basically literally one of those just stuck onto that board, and then the other resistors put around the board. Anyway, I think that's pretty good. We're 11 minutes into a video, which is a lot longer than I wanted to be. But if you've got any questions and you want to drop a line, I'll see if I can get to answer them as quick as I can. But that's basically what I've used. Not a lot. I don't think there's £10 worth there, to be honest. That's including the processor, but it makes it very simple to play with and adjust things using the processor, and that's why I used it. Anyway, thanks for listening, thanks for having a look, and I hope that this helps you out. What I will say, if you want more information on this type of thing, I would recommend you do a Google on Open EVSE. That is a group that have made their chargers. They're all open source. There are parts available so you can build your own chargers, and again it's all open source code, and there is a lot of information there if you search carefully, and all of the protocol and how this works, it's all described. As I say, that's where I started to go. I've built 2 of their chargers, can't fault them, and yes, there's a lot of good information there. So if you want to read up on it, go and just Google Open EVSE. It started over in the States, and also I believe there's a company now over in Wales which do the open energy monitoring, and they also deal with it as well now. But there are links on both the sites to each other, so yeah, you'd find it. Anyway, good evening and have a good night.